Charging of RC circuit. RC circuit is a circuit that consists of a resistor and a capacitor. In this circuit, this is the source voltage E, and this is a switch. We are going to see what happens to the voltage across the capacitor VC and the current across the capacitor when we turn on the switch. And we will plot the VC in this curve, VC versus time, and the IC, the current, in this curve. Let's say the source voltage E is given by 5 volt. So the voltage at this point is 5 volt, and we will show it in the curve. Okay, we will label it here. This is the source voltage E, which is 5 volt. When we first turn on the switch at time equals to 0, okay, this is the time equals to 0, the capacitor initially is fully discharged, which means there's no charge across the capacitor, and therefore the voltage across the capacitor is 0. The voltage here is 0. Okay, at this point the voltage is 0. So the voltage across the capacitor initially is 0. And when the voltage here is 0 and here it's 5 volt, we have a potential difference. Whenever there's a potential difference, it will lead to a current flow. Therefore, when we turn on the switch, immediately current will flow. There's a finite current flow. Okay, so the current at time equals to 0 is finite. There's some finite value of current flowing. As the current flows, the current will charge the capacitor, and therefore the voltage across the capacitor will start increasing. It will slowly increase from 0, 1, 2 until the maximum value of 5 volt. Okay, so the voltage across the capacitor will increase slowly until it reaches the source voltage. When it becomes close to 5 volt, there's no more potential difference because it's 5 here and 5 here. When no potential difference, current will stop flowing. Okay, so over here the current will become 0. So at this point, we can see the capacitor is fully charged. Okay, the voltage across the capacitor is 5 volt, fully charged, and there's no potential difference, so current won't flow. We can also notice that while the capacitor is being charged, the potential difference between this point and this point is decreasing. Okay, over here it's 5 and then becomes lower, lower and lower. Therefore, the current will also decrease. Okay, if the current is basically the difference in the voltage over the resistor. So when the voltage difference decreases, current will also decrease. So current will decrease like this. Okay, and at this point is fully charged, so no potential difference. It's 5 volt here and 5 volt here, and therefore the current here is 0. Okay, so this is what happens when we are charging the capacitor. The voltage increases and the current decreases. Now we can also see where at the time 0, the capacitor is behaving as a short circuit. It's just behaving as a wire. Okay, if I can redraw the curve at time equals to 0, we can actually replace the capacitor with just a wire. Okay, there's no potential difference, and the current is, we can find the current here using Ohm's law. Okay, the voltage is E, resistance is R, so the current here at the time 0 is just E over R. And when the capacitor is fully charged at this point, the capacitor behaves as a open circuit. Okay, if I redraw the circuit, it will look like this. It's an open circuit over here. Therefore, we find there's no current flow. I is 0. Okay, and since the voltage here is 5 volt, the voltage here is also 5 volt. There's no current flowing, therefore no voltage drop across the resistor. If we want to find the current at or the voltage at any other time, for example, if I want to know what is the voltage at this time, then we can refer to the nodes. The equations are given here. Okay, this is charging of the capacitor. We have seen the plot. When we turn on the switch, the capacitor will slowly charge, the voltage will increase. At any point, if I want to know at this time what is the voltage, we can use this equation. Okay, similarly for current, at any time, if I want to know what is the current, I can use this equation. So that's all about charging of a capacitor.